You've all probably seen enough of this. I won't dwell on that too much, but I thought it was important to understand kind of the way the global address stuff is handed out and delegated, because that plays a big part in your address planning. So basically the first 3 bits are assigned by IETF. Currently they have assigned 001 to the IANA. IANA then uses the next 9 bits to assign things to the regional internet registries. There are 5 regional internet registries on the world. They each cover basically a continent. ARIN covers North America and parts of the Caribbean, mostly the English-speaking parts of the Caribbean, 21 Caribbean nations if I remember correctly. From there to the right, it gets a little bit fuzzier. Somewhere up to 20 bits, if it's an ISP allocation, is assigned by the regional internet registry to make a /32. Larger ISPs can get shorter prefixes, 28s. Hurricane actually was burning up enough of their /32 that we recently got an additional /24 from ARIN. If it's an end site assignment, the RIR may assign the next 36 bits to produce an end user /48 for a single end site, or if an end user has multiple end sites, they may request multiple /48s in the form of a 44, a 40, a 36, etc., depending on how many end sites they need to support. The important and key thing to remember here is that if you need more than the minimum allocation for your type or assignment for your type of organization, that's okay. It's okay to ask for a bigger allocation or assignment. It's easy to get a bigger allocation or assignment, and that is expected, and that is what you should do in your address planning. You should not start with the minimum assignment or allocation and then figure out how to make your addressing fit within it. Drawing this up graphically so that you can understand just how much extra space there really is in V6. These are kind of drawn somewhat to scale. So the first bar up there is the complete V6 address space, and 2000::/3, which is what is currently allocated to IANA for global unicast, is just that little 1/8 chunk of it. So 7/8 of the address space is still basically available for IETF purposes other than what's been assigned to IANA for global unicast so far. If we blow that 1/8 of the address space up, we start looking at the /12s that get allocated to each regional internet registry. And in order to make a single /12 big enough that you can see it on the slide, we have to blow that /3 up to 4 of those full width bars on the screen you see there. Blowing that /12 up into 8 full width bars, we get to a point where a /32, there are 204 /32s in each pixel in each bar. So there's a lot of /32s in a single /12. There's 512 /12s in that first /3. Going a little bit further, we see 409.6 /48s in each pixel of the 4 bars that we blew that 32 up into. And then, of course, as we blow up a single pixel or a single /48 into 4 bars, we get 409.6 /64s in each pixel. So many, many, many orders of magnitude more space than you're used to working with, which means you need to change your thinking about address allocation and assignment. Conservatism is actually harmful and will cause you a lot of grief. So you need to take all that V4 think of dense packing addresses and figuring out how many hosts you can cram onto a network and putting these all into tight little things and you know, being super conservative so as not to waste anything. That all needs to go and stay in the V4 world. If you bring that into the V6 world, you're going to do more harm than good. So the first rule I want to tell you about address planning is do not oversimplify too much. There are a lot of people running around doing what I do, but they go to conferences and they say, yeah, ISPs get /32s and end users get /48s and everything's simple. Well, everything is relatively simple, but it's not that simple. Not all end users are the exact same size. Okay? Every end site should get a 48, and in my opinion, that's every end site, whether it's a residential house or a commercial building or a tenant within a commercial structure that supports multiple tenants. Each individual end site should get a 48. There is no reason not to do that. We've got plenty of address space to do it and still have gazillions of addresses, gazillions of networks left over. There's just no harm in doing it, and there's a lot of benefit that could potentially come from it for future planning and capabilities. So I'm a really strong proponent of /48s for everybody at the end site level. And note, end site is not the same as an end user. A business that has 16 branches is at least 16 end sites, not one end site, okay? ISPs should get at least a 32, but if the ISP is more than a very small ISP, they probably need more than a /32. Hurricane Electric is what I would call a medium-sized internet service provider, and to support our deployment, we found that we needed a /24 of IPv6 to do things right according to the algorithm I'm going to show you here in just a few moments. Planning a trial really doesn't have a whole lot of use in this process. There is no reason to do an address plan for your trial rather than just doing an address plan for your deployment and then having your trial be a subset of that deployment address plan that you've put together. Take your best stab at planning your real deployment and use that. If you're right, then you don't have to renumber a bunch of customers when you go from trial to production. If you turn out to be wrong, you're probably going to get a better idea of how and why you were wrong and be able to do a better job on your actual production plan when you do it again. Don't start with a /32 and figure out how to make all of your needs fit inside of it if you're an ISP. Start by analyzing your needs and work from the bottom up, and then apply for the prefix that will support that. It is worthwhile in your analysis to try and align your allocation units to Nibble boundaries. If you can align on Nibble boundaries, then you don't have engineers having to do bit math in their head. And when I looked at some of the bigger internet outages over the last 20 years, I found that roughly 80% of them related to engineers failing to do bit math correctly in their heads on the fly on routers. So if we can take the bit math out of the equation, we can actually reduce internet outages quite a bit, potentially. Does everybody know what a Nibble boundary is? It's a single hex digit, 4 bits. Okay, so I'm going to talk to you a little bit about how to do an ISP address plan. Start with the number of end sites served by your largest POP, okay? Let's say you've got 3,000 end sites. To round that up to a Nibble boundary, the next step up is 4,096. The step beyond that would be 65,536. So as you go up in Nibble boundaries, things get very large very quickly. It doesn't take very many nibbles to fit just about anything you need. Once you know how many bits you need to support the number of end users in your largest POP, you need to look at the number of POPs you need to support and round that up to a Nibble boundary also. So let's say you have 140 POPs. We would round that up to 256, which is 8 bits. So we've got 12 bits, 4,096 per POP, and 8 bits to number the POPs. And the way that ends up looking is we add those together. We get 20 bits that we need left of the 48s that we're going to assign to the end users in each POP, or the end sites supported by each POP. So 48 minus 20 is 28 bits. This ISP would logically apply for a /28. You can probably squeeze this ISP into a /32 if you really needed to, but you're going to find yourself doing a lot more bit math. You're probably going to have to deal with some variable-sized allocations, and life is going to get a whole lot harder, and there's no need to do so, at least in the Aaron region, where policy fully supports using this Nibble-based allocation mechanism. Once you know what size block you need, apply to the RIR and get the block. It's pretty easy, pretty straightforward, especially in the Aaron region where we just streamlined the ISP policy through policy proposal 2011-3. It lines up exactly with the text here. You literally can tell them, I've got this many end sites in my largest POP. I'm going to give everybody /48s. Therefore, I need this many 48s per POP, rounded up to a Nibble boundary, that's this many bits. I've got this many POPs, rounded up to a Nibble boundary, that's this many bits. And so therefore, 48 minus X minus Y is this. That's the size allocation I want. And Aaron's going to go, okay, your documentation's in order. We believe you. Here's your address space. If you are a single-homed end user, you probably need to get your addresses from your upstream. If you are multi-homed, you can actually go directly to the RIR and get your addresses, and you may want to do so. There's a little bit of bad news. If you're not in the ARIN region, the address planning methodology that I just described may or may not fit within the policies of some of the other RIRs. This means you might have to negotiate to a smaller block. All of the RIRs have open policy processes, so you can submit a policy proposal to enable this kind of allocation there, but that might not help you immediately. The situation in APNIC is that Prop 96 is actually under consideration. This slide was updated before Busan, but it's still on the mailing list for consideration in APNIC. ARIN has actually started implementing 2011-3, so unless you need more than a /24, you can currently go to ARIN and get what you need under that policy now. RIPE, it's mostly permitted by their existing policy, but it's not, the wording doesn't line up exactly. So there may be some corner cases, and it hasn't yet been discussed in AFRINIC or LACNIC. The good news is that having things on Nibble boundaries is convenient, but it's not vital. It does help with IP6.ARPA delegations. It is a big help in human factors and reducing human factors related outages. It improves routing table management, and it also improves the ability to do prefix lists by simplifying those quite a bit. But the techniques that I'm going to show you in the following slides work either way. So the next step, once you get your allocation from the Regional Internet Registry or from your ISP, is to start carving it up into the chunks that you're going to need to deploy. Well, it turns out, for the most part, you already did this, right? Because you figured out what chunks you needed, and then you put the chunks together to form your allocation request. So breaking them back apart is just sort of that same process in reverse. So you take the number you came up with for the number of pops, round it up, convert that to a number of bits, 8 bits in our example. Take the RIR /28 that you got, add that to the above number, 28 plus 8 equals 36. So you assign a /36 to each pop, and that's going to do the trick for you. Now we need to give address assignments to our pops. So what I like to do is to take that first /48 out of the whole allocation and allocate that to the infrastructure of the ISP. So, you can use a /64 for your loopback addresses. You can use other /64s for point-to-point links, for, router connection subnets, for aggregation subnets, for your web servers, for your DNS servers, for all the different little things that, you have to build out in your infrastructure to support your customers. Each pop is going to get a /36, so that means we have 2 hex digits that designate a particular pop. Unfortunately, in our example, that's going to be the last digit of the second group of hex digits and the first digit of the third group, so it's going to be X:Y. We've got 2 options in terms of how to carve this up into /36s. The simplest strategy, and the one that we usually use in IPv4, is what's known as sequential allocation. It's very simple, it's very easy to follow. All your free space is in front of you, all of your allocated space is behind you, and you just allocate the next chunk that will fit. And if you've got holes behind you that you've got some small allocation that will fit in, you use up one of the holes before you go out into the bigger empty space. The disadvantage to this is that pop 2 comes right behind pop 1 and pop 3 comes right behind pop 2. So if later pop 1 needs to expand, pop 1 either has to get an additional prefix or you have to renumber pop 1 into a bigger prefix. We can do another technique which is called allocation by bisection. And what allocation by bisection means simply is that we take the largest free chunk of space, we take the next allocation we need and we put it in the middle of that. And we just keep repeating that process, cutting the big holes in half each time until things get a little bit more dense. The advantage to this is that it greatly simplifies your growth process and provides for a very strong probability that as things grow, you can simply expand the bit length of the prefix to the left and make it so that you don't have to renumber anything, but you still have a single prefix per pop. This is very useful in terms of aggregating routes. The disadvantage to this is that math is hard for some people. And so you might need to think about it a little more than you would have to think about just grabbing the next chunk. So put a little more simply, basically it just means cutting things in half, just like if you were cutting up a pie. Okay, we cut it in half again, then again, and finally we make a fourth cut. Sorry. I got ahead of the animations on the keyboard and now it's not sure where it is. Okay, so it's a very similar process for IPv6 addresses. If we start, for example, with 2001 DB80 as our /28 that we get from the RIR, we already allocated DB80:0000 as our first /48 to our infrastructure. So now our available space ranges from DB80:0001 to DB8F: and then a whole lot of Fs. If we cut that in half, we get DB88:0000/36 as our next big chunk that we can allocate. That leaves the largest chunk between DB88 and DB8F. Cutting that in half, we get DB8C, et cetera, et cetera. If we make a whole bunch of cuts, we allocate 19 pops, for example, we end up with a table that looks like this. You'll notice that the address space is cut in half between the left and the right columns. So the first allocation is at the top of the left column, second allocation is the top of the right column, the third allocation to pop 2 is midway down the left column, the third allocation to pop 3 is midway down the right column, and then a quarter of the way down the left column we see 4, the right column 5, the 3/4 of the way down the left column 6, 3/4 of the way down the right column 7, and then we just keep filling in the holes. By doing that, most of the 36s we created have 15 more 36s between them and the next thing we've allocated. All of them have at least 7 more 36s available in front of them. That means we can expand every single pop we've allocated, all 19 of those, to a /35 before we even have to consider assigning a new prefix. Sorry, to a /33 before we even have to consider assigning a new prefix. And in most cases, we can expand all the way to a /32 in a given pop before we have to consider assigning a new prefix. So you get a lot of room to grow without having to change any numbering. All you have to do is change the prefix length. By default, at /36, each pop has room for 4,096 /48 customer insights. Insights that need more than a /48 should be relatively rare. And by this, I mean an insight is a single customer location, not a single customer. Many customers will need more than a 48, but for a given building, 65,000 subnets is probably enough in most cases. With that, I will open it up to any questions you guys have about address planning. I'm happy to discuss or debate any of the issues, but that's pretty much what I have for you. It's just not that hard. Questions, comments, rotten fruit? Yes, sir.
So in the old days, we tend to line our VLANs with our subnets. How are you addressing that now? Are you following those networks now that you truly need to have segregated into VLANs and then just assigning a /48 to them?
Well, so I'm not sure I follow the question. A VLAN and a subnet are synonymous usually, and most VLANs would therefore be N64s, not 48s.
So are you seeing a huge collapsing down of the VLANs now?
No. I don't see any reason to aggregate to put networks together just because the address space is larger. You can put if you've got a VLAN with 5 hosts, you can assign it a /64 and you're fine. If you've got a VLAN with 1,000 hosts, you can assign that a /64 and that's fine too. But I didn't even get down to the VLAN level here. I got down to the POP level and then what you assign to an end site served by a POP. The VLANs would tend to be within the end sites, or for infrastructure within the POP. So those would tend to be /64 individual network assignments. Yes, sir.
What is your policy on, or how do you guys handle the router interfaces? Are you using particular number like .1 equivalents in the IPv4 space, or relating the MAC address?
I've seen all of the different approaches used. I personally don't use : :1 and : :2 because of the ease with which that makes abuse targeting more readily available to somebody that wants to target you. I will usually use : some large number : 1 and : some large number : 2. I don't pick that number completely at random. I use pretty much the same number in lots of different places, but it makes it a little hard to just sort of find that number and then abuse it. So there are lots of different alternatives. Some people are suggesting using 112s. Some people suggest using 127s. I personally don't. I personally think 64s are fine for point-to-point links. Yes, sir.
What about sites that have both, that have two links, different ISPs?
That would be multi-homed, in which case I would suggest getting a provider-independent prefix from your regional internet registry and then using BGP and an autonomous system number to advertise that same prefix to both upstreams. Ed?
Can you define for everyone what a site is from the ARIN definition?
The ARIN definition of a site, and my idea of an N site, since I wrote the ARIN definition, is a single building or structure or a single tenant in a multi-tenant building or structure.
So
An apartment would be a single tenant structure within a multi-tenant structure. Another example would be if you've got two students in a dorm room. The policy as I've proposed it and as it has been adopted would actually support assigning a /48 to each of the two students in that dorm room. I'm not saying you necessarily have to do this, but the policy supports being that liberal, and that's a good thing. Yes, sir.
So one of my buildings is a Pentagon.
Okay.
How many sites? What's a good breakup of sites there?
I have no idea because I don't know who the tenants in the Pentagon are in detail. But you have at least 5, right? Because you've got the Army, the Navy, the Air Force, the Marines, and the Coast Guard. So at the very least, you've got 5 tenants and 5 end sites. Probably if you consider all the different divisions of each of those and all of the agencies that I don't know exist, you probably have many more end sites within the Pentagon. And each of them are entitled to a 48 as far as I'm concerned. Yes, sir.
And then, did you end up writing the ARIN end user allocation breakdown for like when you hit 12 sites, when you bump up to user?
Yeah, as you get, when we're rounding up to Nibble boundaries, if you're at 11 out of 16, then you round up to 16. If you hit 12, we actually require you to have like a 25% min free. So when you hit 12, we'll bump you up to 256. We won't make you get all the way to 16 before you get bumped up to the next nibble. Okay? If you hit 3,072, instead of 4,096, we'll bump you up to 65,536. So you get lots of room to grow with the current ARIN policies. We think that's a good thing because we think it'll improve aggregation, and we don't think we're going to run out of address space. Now, this is kind of an experiment, and if we burn through, say, 20/12s in the next 10 years, we might consider a more restrictive policy with the other 592 of them. But for now, we're going to go with this and see how it goes. Yes, sir. It's documented in a number of places. I think in the ARIN policies, it reads something on the order a number n such that 2 to the a number n such that 2 to the n results such that n, a number Basically, it's n mod 4 equals 0, and 2 to the n would be the number of things you get. So 4 bits, 8 bits, 12 bits, 16 bits. And the reason that we do that is because 4 bits equals 1 hex digit. So a single digit in the IPv6 address is 4 bits or a nibble, or half a byte if you want, if you believe in 8-bit bytes. Yes, sir? You've got some which?
Some locations that are multi-buildings.
Yeah. Each building would be an N site.
Not the campus, building.
Well, you can do it either way. It's up to you, but the policy supports you treating each building as an N site and giving each building a 48. You can give the campus a 48 if you want to. Nothing says you have to be this liberal. It just says you can be this liberal. Yes, sir.
Do you want to talk quickly about multi-homing for addressing when you're going international? So between Aaron, Wright, others, about if there's any policy set about dealing with how much address do you get from Aaron versus how much do you get from another site?
There's no strong policy there, and as a general rule, you can number your entire international network from space from your home region if you want to. There are some countries where different people and different customers may have different attitudes about whether the space came from their region or not. And so as an ISP, in order to meet customer satisfaction demands, you may need to get local space in each of the regions to support those customers. But as a general rule, you can get all of your space from your headquarters RIR if you want to do it that way. The exception would be Afrinic, which has actually specifically passed a policy. I don't know whether their policy relates only to v4 or whether it relates to v4 and v6, but it requires you to use the Afrinic resources primarily in the Afrinic region. But other than that, the other RIRs don't care where you use the resources as long as you have a network presence in the region. Any other questions? Okay, well, thank you very much for your time.